We are on the section 6.1 and 6.2, sets and Venn diagrams. Let's see what they are, okay, on your page 48. So let's talk about Venn diagram first. What are those? Okay, so we are using Venn diagram to show the concepts, to visualize the concepts. Okay, let's see how we are going to do that. Let's see some examples first and see what do we mean by that. The Venn diagram to help us to visualize what's happening. Okay, so we say for three persons A, B, C. Okay, we describe their hobbies. So for person A, he does skiing, snowboarding, singing, cooking, traveling. And for person B, say she's doing skiing, reading, chess, dancing and traveling. That's her hobbies. Okay, and another person, she likes snowboarding, drawing, singing, dancing and traveling. So you look at them, then we like to know what do they have in common, or what's the difference, right? So compared to person A, person B, what do they have in common? Skiing, what else? Singing, dancing, or traveling, right? Then for person B and person C, what do they have in common? Let's see. How about dancing and traveling? Okay. Then for person A and person C, that would be snowboarding, what else? Singing and traveling, right? Then for all three of them, they all like to do what? Traveling. Okay. Then when we look at it, we have to kind of go through the list and then compare. If we do the visualization, let's see how it works. Okay, then we use picture to show. Okay, actually Venn diagram just two circles or three circles. Three persons, we use three circles. Two persons, compare if I use person A and person B. Okay, then we say, what do they have in common? For person A and person B, skiing are the same, traveling are the same. The rest of them are different. So what do we do? What do you think? Two circles, then in between means what? For both of them, right? So what do? We can write down the skiing here and traveling, right? Both do that. But for person A, he has more habits, right? So for snowboarding, and what else? Singing and cooking, which the person B, right, doesn't have that habit. So for person B, then she does reading, chess, and dancing. So if we do that way, can you tell by visualizing right away, right? So you can tell what do they have in common, then what's the difference by individual, right? Okay, so if I want to describe three persons together, what can I do? I can say, okay, this is a person A, person B, right? And person C here. Okay, how we are going to visualize them? So you can look at this way. Okay, so what do you think? What do we put in the middle? in the middle here. Here belongs to what? All of them, right? So what do? We know traveling is the thing, is the hobby all of them like to do. So you will put what? Traveling in the middle, right? Then what do you think is this part between A and B, right? So between A and B, besides traveling, they both like skiing. So we do that, right? Skiing here. That means skiing belongs to A and B, but now C, see? Now the C. But the traveling belongs to all of them. Then how about A and C? Between A and C, we know they have what? Snowboarding the same. What else? Singing and traveling, right? But the traveling we already described, right? We are talking about between A and C. Besides traveling, between A and C, what do they have in common? Snowboarding and singing. So we do snowboarding here and singing here, right? So we described what? Between A and B is these two, right? Between A and C, that would be what? Here, right? Traveling, snowboarding, and singing. How about between B and C? Between B and C, what do they have in common? Traveling, what else? Dancing, singing, drawing, skiing. No, between only dancing and traveling. So between B and C is what? Dancing and traveling. Traveling we already described it, so we put the dancing here. So that's what they have in common. So you do it from inside to outside, right? What do they all have in common? Traveling, put it in here, belongs to all of them. Then you do between two of them, A and B here, right? B and C is here, right? And A and C would be what? Here. Then what else? Sometimes they do it individually, not with others, right? Their habit, not similar to others. So for here, for A, besides skiing, traveling, snowboarding, and singing, he does cooking as well, but only by him. Only himself likes to do that. B and C doesn't like it. Didn't like as a hobby, right? How about B? B, besides skiing, traveling, and dancing, she also do what? Likes to do reading and chess. Okay, so it's reading and chess only for the person B. How about for person C? Besides snowboarding, singing, traveling, and dancing, she also like to do the drawing. So only by herself drawing, right? So that's how we describe by visualizing, like here. If for three persons, if we do like this, then we can tell what's the hobby. Only A likes, not the B or C. Only B likes, or those two. Only C likes is this. Then this in between belongs to two of them or three of them to describe this way. Got idea? That's how we visualize using the Venn diagram. Okay, then we see if we deal with numbers, deal with other things, probabilities later, you can use this to help you to see it. Right? Now let's talk about something called sets. Okay, we just talked about Venn diagrams. Now let's talk about sets. Then for sets, it's a fundamental things in math. We use those to express an idea. Okay, so we have to introduce to you first what kind of things we are talking about, the vocabularies and the notations we use. Okay, something called set. Okay, something called element. Okay, something we use, call them complement to each other. Okay, and we are going to do operations on them. Okay, for operations, we have something called intersection and union. Those the concept we are going to use to describe the sets. Okay, and another thing is called cardinal numbers. Okay, cardinal numbers. Okay, so those are the terminologies we are using for the sets. Okay, then we see what kind of symbols we are using. So the set, what is a set? Okay, a set is a collection of something. Collection of things, bunch of things put together, we call a set. Okay, so we just use the numbers for our convenience and to express the idea. So the symbol we use for a set is like, okay, a set of A or a set of B. Okay, so I say, okay, my set, for the set A, I will do what? I just say, okay, I use the curly bracket, the basket, put the things in there. Set is a collection of things. The things in the set A, we say, okay, I have 1, 2, 3, 4, 5, 6. I just put a bunch of things. And a set of A is bunch of things. The things are what? 1 to 6. Then I say, okay, my set B will be 4, 5, 6, 7, 8. We can do that. Okay. Another thing is, so A and B are sets. Okay. Then if I have nothing in there, I will say, okay, I have a basket, nothing in there. Then we call this empty set. Okay, then we use this symbol and slash. That's called empty sets. Okay, then when we visualize, we use the diagrams to show it's like, okay, this is my whole thing. Okay, then I call this is my universe. Then we call this one what? Universal set. Then everything we will put in there. Okay, we call it U. That's the things we are dealing with. Okay, that's called sets. Then we use the curly bracket to show the symbol. Okay, then next thing we are going to talk about is called elements. What are elements? Elements is the things in the set we call elements. Okay, so we say A is a set. What are their elements? What do you think? The elements will be what? 1, 2, 3, 4, 5, 6, right? For set B, the elements would be 4, 5, 6, 7, 8. For empty sets, what's the element? Nothing, right? So individual things inside the set is called what? An element, okay? Another terminologies we use called complement. So we say a complement of a set A consists of what? Okay, it's all the elements. That would be all elements, okay, that are in the universal set. Okay, but not in A. Complement, say this, okay, two persons are complement to each other. That means one person has, another person doesn't have it, another person has, the one person doesn't have it. So they complement each other. So complement, for what's complement of A, that would be what? The things outside of A, okay? So universal set is here. If A is here, where is the complement of A? That will be the remaining part, right? That's called complement, okay? Then for the element sets, complements, okay, we are going to do operations. Just like, all the math, we are talking about, operations, add, subtract, multiply, and divide, okay? So, but for sets to do operations, we call intersection and union. Okay, intersection, we use this symbol, like upside down U. Union, it's U. Okay, so what are intersections? So if we say intersection two sets, okay, we talk about how to operate between two sets. Okay, so if we say A intersect B or A union B, what do we mean by that? Intersection means what? Means the intersection for A and B means what? A and B element of the elements that are common to both sets. Okay, so intersection means what? It belongs to both of A and B. Okay, then union means what? The union set of A and B means what? Of all collection, of all elements in either one of them, either A or B or both. Okay, that's called union. So let's see what kind of symbols, notations we will use for complement, right? This is a complement of A will be what? Outside. Then we use this symbol. Little superscript of C means complement of A. So where is the complement of A for this case? If A is here, AC complement will be what? This portion, right? So this one will be complement of A, right? Then if my A is this, B is this, then what is my, for these two, right? Here. So what is my A intersect B? That means of elements that are common to both sets. What do you think? What's in common? 4, 5, 6. Right? So A intersect B, that would be your 4, 5, 6. Right? Then for union means all elements belong to what? Either one of them or both of them, all of them, right? So A union B, you unite. So what do you do? So you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Also 7, 8. But you don't repeat 4, 5, 6 because all the elements, you only describe it once. Okay, that's the symbol. Both are sets, but we use the curly bracket to put it in, then show the elements belongs to intersection or the union. Okay, so for intersection means what? For A intersection B means what? We use this logic thinking N because the elements has to be belongs to what? Both sets. Okay, then union means what? Or, either or. Either in A or in B. Right? So, if you look at the Venn diagram, how would you see it? Okay, that's my A, that's my B. What do you think? With a Venn diagram for those, what do they have in common? 4, 5, 6. You put it there, right? Then belongs to A only, 1, 2, 3. Belongs to B only, 7, 8. So that's your A, that's your B. B is 4, 5, 6, 7, 8, right? So intersection, that would be where? In here. Is that right? That would be your A and B. A intersect B. Then union would be what? The whole thing. 1, 2, 3, 4, 5, 6, and 7, 8. Okay? If you look at the Venn diagram, so this part would be what? A intersect B, right? Then where's A union B? Would be the whole thing, including A and B. So whole thing would be what? A union B. If you use the Venn diagram to see it. Right? Pretty straightforward, right? So those would be the terminologies we are going to use and operations like adding and subtracting, multiplying, dividing. Okay, but for the sets, we use what? Intersection and union. That's the operation for the sets. Another concept we need to do is called cardinal numbers. And what are cardinal numbers? They is the counting, all right? It's the total count of the set. So let's see, what's the cardinal number for A, for set A? That would be 6, right? What's the cardinal number? That's just your counting number. So what's the cardinal number for the set B? That would be 5. What's the cardinal number for the empty set? That would be 0, right? Then what's the cardinal number for A intersect B? That would be 3 of them. What's the cardinal number for A union B? That would be total how many? 8 of them. Okay, we are going to count the numbers with the terminologies we use to present the idea how many elements in a set. Okay? So we introduced the vocabularies and notations and Venn diagrams. Then we see how we operate them and how we are going to show with Venn diagram to show the concepts. Right? Okay, let's see some examples on your page 49. Okay, we are going to see the operations on the sets with Venn diagrams. Okay, so example 1, say for the set A, it has what? 6 elements in there, 1 through 6. B has what? 5 elements in there. So operations are what? A intersect B or A union B, okay? Before we do that, we just see the diagram. How do we do the diagram? That's A, that's B. So what do you think? You put it in the middle. 4, 5, 6 are the same, so you put it here, right? Then A, besides 4, 5, 6, it has 1, 2, 3. B has what? 7, 8, right? That's how we see with diagram for the sets. How about second one? You have A and B, right? What do they have in common? 4, 5, 6, right? So we put a 4, 5, 6. Then A have what? 1, 2, 3. B has nothing else besides 4, 5, 6. So we will just leave as is. Then for the cardinal table, cardinal number concerns, so that will be total how many? Would be what? 8, right? Then total how many? Total would be, total number would be what? 6. Then for example 3, that's C. How should we do that? A and B. Oh, they don't have anything in common. So I don't have to put them together, right? So A is what? 1, 2, 3, 4, 5, 6. B is what? 7, 8. It's nothing in between. There is nothing in common, right? How many total numbers we have? We still have A numbers. Okay. Then that's C. If we use this one is using the numbers to show the Venn diagram, okay? Another one, we just use the Venn diagram to show the concepts. Okay, let's look next example for the Venn diagrams. Okay, we have 2 sets, A and B. A is first circle, B is the next circle. Okay, then we show the operations for the complement and for the intersection, or the intersection for the complements. Then where are they? In the picture. So your square is what? The universal sets. So A and B are in it, all right? A is first circle, B is first circle, second circle. So for operation intersection, A and B, that will be where? Here, right? They intersect. Then where is the union? A union B, that will be the A union B, right? Then let's check the complement sets. Okay, A is here. Where is A complement? Complement of A means what? In the whole thing, it belongs to universal set, but not in the A. That's called A complement, right? Complement of A. So it doesn't belong to A, should be what? Outside of A. Right? Doesn't cover A. Right? So for complement of B, it doesn't belong to B, but everywhere else. So where is it? Not in B, so that will be outside of the B. Right? Pretty straightforward. Now, let's look another one. If we do intersection or union with complement, right? So A is here, that's A, right? It's here. then intersect with B complement. Complement of B. Where is so A is here, right? That's our A. Then B complement is what? B complement is this one. Outside of B. So outside of B will be where? Outside of the B. So blue one is outside of the B. Purple one is what? A. Right? Now we want to do the intersection, means what? Belongs to A and B complement. So we want to find something, it belongs to purple and the blue, right? The light blue, which would be where? Where do they intersect? That would be this portion. Is that right? That would be only this portion. That would be your A intersect with B complement. Okay? Then next one, A complement intersect with B. So A complement is what? Outside of the A. That will be outside of, not A, okay? Outside of the A. That's A complement, right? Then B is what? B is here, right? Then the intersect would be what? Belongs to both of them. So in overlapping part, the purple and the light blue, that would be what? Here, right? So that would be your answer for that. Then take a look at the next one. A complement intercept the B complement. So where is A complement? Outside of the A, right? A complement. That's where we are, right? Then where is the B complement? Outside of the B. Outside of B, like this, right? So outside of B, B is here, outside. Not touch B, outside of the B, right? Then we say we want to find the intersect. Intersect of this means you want to find the overlapping part which belongs to what? Both purple and the light green. So that would be both. So that would be here, but not just one of them, right? Intersect means what? Both. So that would be where? Overlapping part. That would be this portion. Got idea? Okay. That's intersection. Let's do some union. So union have to be both, right? Both of, including either or both. Okay. So let's do A complement. So complement of A outside of the A. That would be here, right? Then B complement would be outside of B. Outside of B would be here, right? As long as you don't touch B. Outside of B is here, right? Then union means what? Either or, you have to cover both colors, light blue and purple. So we do union, right? Union means you have to cover everything you indicated. So that would be where? Here, this one, none of them cover, so we don't go there. So we have to cover every one of them. So that would be all here. right? That would be A complement union B complement. How about just A complement union B? So A complement of A outside of A. That's here, not A, right? That would be here. Then, and B, right? Union B. B is what? Here, the whole B. Then we want a union, means cover them all. So wherever you shade it, you will include, right? So that would be here, here, everywhere, right? But not there, because none of them cover it. That would be your A complement and union B. How about A union B complement? So A is here, right? Then B complement will be outside of B. That would be outside of B. Outside of B. Right? Then union means cover all of them, right? You mark the area, shaded area. So everywhere here is shaded, including both shaded. So that would be like here. Okay, so that would be your A union B complement. Okay, so that's how we use the shaded idea to show where is the area covered, right? So we just practice what? The operations intersect and union and Venn diagram on two sets. Okay, let's see next example for set notations. We were using Venn diagram. Now we just use sets, okay? So let's see. First one, if we just have a long collection of numbers that have a clear pattern, okay? Then we use dot, 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 okay? So it's like this. 3, we have a list of a long list of numbers. Dot, dot, dot means everything in between up to 90. So this set has what? 3, 6, 9, 12. What do you think the next number will be? 15, 18, all that, right? So to mean you start here, okay, keep going and end here, like this. Then we ask you, what is the total number of elements in a set? This is a set, right? Total number means what? Cardinal numbers. In these sets, in this set, what do you think? It just you dot, dot, dot means keep going up to this here. How many numbers in there? So total numbers will be what? If you count your fingers, it will take you forevers, right? So what do? You jump by, it's a pattern, jump by 3. So every 3 you jump up to 90. So total how many? Divided by 3. So total will be what? 30 of them. So actually you have 30 numbers in there. This dot, dot, dot is a math symbol. Okay, it's a formal dot, dot, dot. Means we continue go. Okay? We show you how to use dot, dot, dot in a set. Next one, if we just have a collection of numbers that have a clear pattern, like this, but never ends, okay? We use dot, dot, dot with a number at the end. For example, if I have 1/2, 2/3, 3/4, 4/5, dot, 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 curly, right? What do you think the next number will be as a pattern? 1/2, 2/3, 3/4, 4/5. Next one will be what? 5, 6. Next one will be what? 7, 6, and keep going, right? It never ends. So what's the total number of elements in the set? What do you think? It goes forever. You cannot count it, right? So your answer can be what? Infinite, means it goes forever. Or you can say infinity. Infinite, right? Infinity, yes. Or you can say what? Doesn't exist. Because you count it, you cannot give an exact answers. Then we say doesn't exist. That's how we do it. Okay? Look, next one on your page 50. Number 3, it says, if you wanted to describe the set of all people who are over 18 years old but not 30 years old, okay? How would you describe it with a set notation using X, okay? So we are going to use X to show an idea, okay? X is what? The people we are dealing with, who are over 18 years old, but not 30 years old. So over 18 years old can be what? 19, 20, 21, all the way forever, right? It didn't say how old they are, just to say can be 100 something, but not 30. Then we wanted to use the set symbol to describe it. How do we describe it? So you know set, you use curly, right? Then we are talking about elements who are people, okay? So that's X we are describing. Then you put the bar after it, then you put a description here. For the X you are describing. So it says older than 18, so it's older than 18, right? But not 30, so it's not 30. So that's how we describe it formally in a set notation. You will see the set notation later on for different things, but you understand what we are talking about when we write it this way, right? Okay, that's how we use set notation with curly bracket, sometimes with variable. Okay, but you should know how many elements in there. Like here is the first one is fixed. You should be able to count it. If infinite, it's infinite, right? Or doesn't exist. Then we use a set symbol to describe the concepts as needed. Okay. Next one, let's see more Venn diagram examples. Okay, so if we give you a Venn diagram like this, okay, that's my set A, set B. So I have 12 here, okay, I have 12 elements in there, okay, it's not number 12, okay, so if I say 12 elements in A, then in B, I have 14 elements here. Then in between, I have 5 elements. We didn't list it. We just say, okay, like this. Then we ask you how many elements in each set. So what's in A? So total in A would be what? You have 12 and 5. That would be 17, right? 15 plus 5, 12 plus 5. So it's 17. How many elements in the B? In B would be what? Besides 14, you have 5. So 14 plus 5. You have 19 elements in there. Okay? We're just counting the cardinal numbers. Then with Venn diagrams. Okay, so you need to have this concept for your test. So you know how to count, right? Probabilities and stats. Later on, you will learn is what? Counting the chance. How many things happen over the probability. Say 5 elements happened in 100 elements. So your chance is what? 5 out of 100, right? So you have to know how to count it. Then use Venn diagram to help you to visualize it. Let's look at the next one on page 50. Example 2. It says, consider the Venn diagram below that shows the result of study asking students whether their first college class was at the same place they are at now, okay? Whether they are right-handed and whether they are enjoy their experience at college. So what are we talking about? Okay, we show how many elements in each set. We are talking about 3 things. Okay, asking students whether their first college class was at the same place as now. So if this is your first college class, same place. Okay, then we also ask some students, say, okay, if they are right-handed or they are left-handed. They are right-handed or left-handed, okay? If they are right-handed. That means some students, maybe they are still in the same place as their first college and they also right-handed, that will be here, okay? Then another one is what? If they enjoy their experience at the college. So that's enjoying experience in the college. So that would be 3 diagrams. So it should be here, right? Okay. So let's see. They also show you some examples. Show you some numbers. It says 12 here. That means you have 12 person is enjoying the class, enjoy their experience. Then also 12 person still is the first college they have, right? Same place as now. Then also it's right-handed. Then here says 8. Means 8 person, they are right-handed and enjoy the same, they are still have same place as their first college class, right? But they are not enjoying their experience. Then here says 2. It means what? They are enjoying it, right? And still have same class as same place as their first class, but they are not right-handed, means they are left-handed. And what else? Let's see. 15 here. Okay, 15 people, they are enjoying college. They are right-handed, but they're first class, not as the same place. Okay, then what else they have there? Let's see. They also have other numbers. Means 12 there, first class, and still same place, but they are not enjoying it because it doesn't belong here. They are not right-handed. Then here, 6 right-handed person, but they are not in the first, same as the first college class, and they are not enjoying the school, right, experience. And some people enjoyed it, but not right-hand, not at the same place. Okay, you will see some examples. This is just a basic. Then we will see what kind of a test you might have, all right, to use your concept of Venn diagram. But we need to know how to count them first. Okay, here is the question. determine how many students are first right-handed, right hand, and enjoy college. That means it has to belong to what? Both right hand and enjoy. So right hand is here, but the enjoy is here. Where do they have similar situation? Okay, that would be here, right? So that would be 15 plus 12. That would be what? 27, right? And next one, same place, and but not right hand. That means the right hand complement outside of right hand. So same place is here, right? But not right hand, cannot be in right hand. So that would be what? Same place. Oh, that's 22. Okay. Same place. That's the same place, but not right hand, cannot be inside the right hand. So that would be here, right? So that would be 22 plus 2 equals what? 24. Right? We're just counting the portion of the whole thing. Next one, determine what? Enjoy the college. So what do you think? Where is the enjoying the college portion? That would be here, right? You have to count everything inside. That would be what? 10 plus what? 15 plus 12 plus what? 2. You have to count them all. So that would be how many? 25, 27, and 39. Okay, that's how we will count it. So, mainly we use a Venn diagrams to count the things. How many, then chance to happen is, like we said, 5 out of 100, things like that. So we need to count individually or outside or together. Okay? Look at the next example on your page 51. Example 3. Here says, suppose that a group of 40 households was looking at. So you check how many total? Total have 40 households, right? You look at it. 24 of them houses dog. Then 30 of them house the cats. 18 of them house both cats and dog. Sketch a diagram that displays the information. So total is 40. Then some house have dogs. Some house have cat, right? Then they say, okay, for dog, total is what? 24. For cats, total is what? How many? 30. But 18 of them have both cats and dog. So total dog is 24, total cat is 30. Then both of them have what? Dogs and, some of them have both dogs and cats, have 18 of them. So 18 belongs there, right? Then what do you think? How many households they have dogs but not cats? So dogs here but not cats. 18 including cats and dogs. So how many only have dogs? So what do? You do what? 24 minus 18. So 6 of them should be only have dogs, right? Then how many only have cats? 30 minus what? 18. So 12. right? Total how many? Let's take a look. 6 plus 18 plus what? 12. So for the household, have both either cat or dog or both. Total would be what? 6 plus 18, 24 plus 12, 36. So there are 36 households either have cats or dogs or both. Total 36. But we say we check the 40 household. What happened? It means what? 40 minus 36 households have 4 households left. What does it mean? It means what? It doesn't have cats or nor dogs. So you put a 4 here. That means it belongs to 40, but it doesn't belong to dogs or cats household. Got idea? So we use a Venn diagram to show the concepts this way. Okay, it's a little bit abstract, but you will see when you are in the stats class, you will find out it will be handy for you to be able to see it, visualize it. That will help you to think about how to calculate things. Okay, so that will be our section 6.1 and 6.2.